Welcome to this video on lesson 5 of the atomic structure and periodic table unit. In the previous video, we finished looking at the history of atomic models and how these ideas around atoms developed over time. And that's a really important sequence of lessons, not only for students' GCSEs, but it also gives them a really clear insight into how science develops. What we're going to do from now on is actually start to systematically build students' knowledge of chemistry. And it's worth emphasizing before you begin that we are going to be using Bohr's model of the atom. Now, Bohr's model of the atom is wrong. It was proved wrong pretty quickly after he put it forward for various reasons, and we're not going to go into quantum mechanics and why Bohr's model didn't quite work. And it's a legitimate question for students to ask, well, why on earth would we study it? If you just remind them that it's a good model to explain lots of things, and that's why Bohr put it forward, and it's only when they get to much higher levels of chemistry do they need the more sophisticated model that depends on quantum mechanics. So I think it's worth emphasizing that to just preempt those conversations that A-level chemistry teachers have where they say, everything we taught you was wrong, and students are like, what? You told me it was all the truth. Tell them it's a model, and with that knowledge that they've built in the previous lessons, that should be fine. Now, one problem that I find when I teach this is that you've just spent a load of lessons talking about atoms, and yet students still don't really know what you're talking about. So when you're introducing this lesson, I think it's actually worth starting still with something concrete. So I'm going to start with a bottle of water. Something super simple like this. This is a bottle of water. And you could do this as a kind of check on prerequisite knowledge. You could ask students to sketch this on their whiteboards. Ask them, if you were to zoom in on the particle level, and this is something that they've been studying since primary school, so they should be pretty familiar with this. If you were to zoom in on this bottle of water, what would you see? And they can sketch this. It's as good if you do it as retrieval versus you explaining it. But what they should be able to tell you is that you have this random arrangement. Particles are still very close together. It's not like a gas where the particles are far apart. And they are moving randomly with only relatively weak bonds between them. So I'm going to show this random motion at a range of speeds by showing the arrows going in all sorts of different directions and so on. And we've got some inside there as well, which are moving too. But that's a really familiar picture. And what we want to do as science teachers is always build on students' prior conceptions, and this they'll be comfortable. I can assure you by this time, 99% of students will be comfortable visualizing liquids in this sense. But what we're going to do next is zoom in again and say, well, actually, if this is water, what does each one of these particles look like inside? And this is where students might find it a bit more difficult. And again, ask them on whiteboards, but they might go, oh, I'm not too sure about that. The answer that we want to elicit here is that this is water, and this is building on what they learned about in Key Stage 3 in Year 7. The answer is water. What's the chemical formula of water? It's H2O. So actually what this looks like in here is something like this. Each one of these looks a bit like Mickey Mouse, doesn't it? But each one of these is a molecule, and within each molecule, what we were previously calling a particle, we have 2 H's and 1 O. But that's still not enough. Now that they've learned about the history of atomic models, they should be able to identify that this idea, even within the molecule, this idea that the atoms are these kind of hard spheres within the molecule, that's still a Daltonian conception of atoms. That's still this really primitive picture of atoms that we showed them. We showed them how science had developed from there. So we're going to zoom in yet again. You could zoom in on hydrogen. Hydrogen's a bit of a weird one because it doesn't have any neutrons. So it's probably a better idea to zoom in on oxygen. So we can say, look, if you're still thinking about atoms as these hard spheres, you're still thinking like Dalton. What did Bohr suggest they look like? This idea of shells or energy levels and a nucleus, which obviously came from the gold foil experiment. So this is where we can finally introduce the kind of the picture of the atom that we're going to be working with for the rest of GCSE science. So what we're saying to them is, well, look, how did our ideas about the atom change? Well, first Thomson said it was plum pudding, and then Rutherford said it had the nucleus, and Bohr said it had the energy levels. So we're going to sketch this. So we're going to sketch an atom of oxygen, and actually you can give them the kind of sketch that we're going to be doing when we do the electron structure lesson in a couple of lessons time. You can show the different shells like this and show where everything is. So the first thing to say is that this bit in the center is the nucleus. Now I've not drawn it to scale there, and it's important that you stress this to students, that the nucleus is super tiny. Again, we went through that in the lesson on the gold foil experiment. So this is the nucleus. And what I'm going to tell students here is that the nucleus contains protons and neutrons. So this is where I'm bringing in some new information, and I'm just going to verbally tell them that protons and neutrons both have a mass of 1. So all of the mass of the atom, essentially all of the mass, is inside the nucleus, because actually, as we'll see, the electrons have a very tiny mass. Now again, I could write that down, but actually what I want them to do is fill out the table with all the information as the kind of deliberate practice task later on in the lesson. So I'm going to try and just tell them verbally. I'm then going to check on whiteboards that they were listening, and then I'm going to get them to make the notes themselves. What I will do though is I'm going to tell them where the protons and neutrons are found, and that's inside the nucleus. I'm then going to tell them that these are the energy levels, and what we find is that the electrons are on the energy levels. And again, we don't need to go into why this is the case yet, but I'm going to draw the 6 electrons on the outer shell, the 2 on the inner shell. I'm going to label these are the electrons. And I'm going to tell them, again, these have a very low mass of almost 0, hence what we said before, most of the mass of the atom is inside the nucleus. Now the final thing that I need to talk to them about is charge, these relative charges. And again, this is where I might, I'm sure you will have tricks, or people in your department will have tricks. I tend to talk about P for proton, P for positive. So protons have a positive charge, a charge of +1. Neutron sounds like neutral. Neutral means 0 charge. So I might underline the neutral bit of that. And then I tend to do it with a kind of, what do they call it in English? Assonance, negative and electrons. It's got that same S sound. So the negative ones are electrons, and that's how they remember that electrons have the negative charge. So the first part of this lesson, I'm going to stop this video here, but the first part of this lesson kind of ends here. It's just giving them that information. Firstly, where are the protons, neutrons, electrons in the Bohr model? Secondly, what are the relative masses? Thirdly, what are the relative charges? In the next video, we'll talk about how we put that into the kind of nuclide notation.